So for this question, we're going to look at qualitative electrolysis. This is the second question that I'll be working. So watch the previous videos if you are a little confused. Now, when we're doing these, when you get this question, I expect that you highlight the keywords that are there. So it says calculate the mass of lead. So it says mass of lead, that's what we're calculating, produced at the cathode when a current of 5.0 amperes flows through molten lead bromide for 16 minutes and 5 seconds. Right, so what we're calculating the mass of lead. Don't make the whole molten lead bromide trick you, lead 2 bromide trick you. We're calculating the mass of lead, that's the focus right there. And we're given the current in amperes, which is 5.0 amps. And we're also given the time in minutes. So we need to calculate this. Alright, so to calculate the mass, the first thing we do, step 1, as I said in the previous video, step 1, you first calculate your Q. That's the first thing you do, Q. Where Q, which is the quantity of electricity, is equal to I times T. And in this question, the value of I is 5.0 amperes times time. I think it was 16 minutes and 5 seconds, yes? Now we have to convert all of the time into seconds. So it's going to be 15 times 16. 16 times 60. Right, whatever we get there, we're going to multiply this. Sorry, add. What is going on here? We're going to add this to the 5 seconds that we already have. So 16 times 60, what's the answer that you got? 16 times 60.
960.
16 times 60 is 960 plus 5 give us 965 seconds. And then we times that by our amperes. And the answer that we get here is 4,800.
Miss, when we are doing it, we're supposed to set out Q equal.
Yes. Just in case the answer that you get is incorrect, I expect you to write your formulas.
Okay.
Because sometimes the answer we get kind of not so much up to there. So the working out the formulas always helps. I've seen questions where they actually give you the formula for Q. It's just that you need to know what goes where, what to insert where. Alright, now the second thing that we do in this question is that, so first thing was Q. The next thing that we do is that we write our half equation. And on CSEC, they oftentimes give you the half equation sometimes before, but you have to know exactly which half equation to use and which electrons to use. So the purpose of our half equation is to find out the amount of electrons that flow around the circuit. I remember that that amount of electrons is directly proportional to the mass produced, right? So it's very important that we have to write the half equation so we know the amount of electrons going around our circuit. We can't know the mass without the amount of electrons. Remember that those two, Q and then M, all of those right there, those are directly proportional. If the mass increases or if the electrons increase, then the mass is going to increase. If the quantity of electricity increases, then the mass is going to also increase. So you have to write your half equation. Do not forget it. So in this case, it says calculate the mass of lead produced. So the half equation that we're going to use is the one for lead. Right? And note that this II here, this Roman numeral here, actually gives us an idea of what the charge is. And also, this right here, molten, suggests that it is melted, like, you know, like you have lava flow, like thick lava, think of it that way. So we have an ionic compound that is melted. So it's in the liquid state. It's not aqueous, there's no water present, it's simply in the liquid state, so the state is going to be L. So let me write that here. Our our element symbol for lead is Pb, right? And lead has a 2+ charge. As I said, this is a giveaway for the charge of lead, that 2 right there. That's the charge for lead. And the state is liquid because it's molten. To give, I'm just going to leave a little space just in case I need to write my electrons there. Lead, and at the end of electrolysis, we're always gonna produce the substance in its elemental form, right? So in the case of lead, in its elemental form, lead is a metal, right? It's a metal, and metals are solid. So I'm just gonna put that there. Well, most metals are, yeah, metals are solid, most. Right, so lead is a solid right there, and in its elemental form, the state is now neutral. It's a neutral solid. Now, what's gonna happen? Well, what we do next is that we're gonna insert our electrons. Know that this is already balanced. We have one on both sides, so we're fine. We're gonna insert our electrons, and the electrons, the amount of electrons, and I would have given you this equation before. Number of E is equal to the difference in charge times the amount of atoms. So in this case, we're going from 2 plus to 0. The difference is going to be 2 plus minus 0, right, times the amount of atoms, and we're looking at the amount of atoms on one side since it's already balanced. Right, it's 1 atom, as you can see, 1 right there. The number 1 in chemistry is invisible, right? So even though we're not seeing it, it's actually there. So what we get here, 2 minus 0 is 2 times 1 atom, which gives us 2 electrons. So that's how we get the amount of electrons. Now, what side do we put these electrons are? And this is dependent on our number line, right? So, let me do it this way. We're going from 2 plus to 0. We're going down the number line. We're going to the left. So our electrons are gonna go on the left. So it is gonna be Pb2 plus liquid plus 2 electrons to give Pb neutral solid. Right, that's our half equation. And now we see where our electrons come in, or how we get the electrons.
Miss, the 2 always have to be down that side, the E have to be beside the 2.
Yes, it's beside, it's beside. It's beside. Step 3, we calculate the mole. And mole in electrolysis is not the regular mole equal mass divided by molar mass. Mole in electrolysis is equal to Q times A divided by mole of E times F. Q was the quantity of electricity that we calculated earlier. That quantity was what do we have? 4,800?
$4,825.
How do I have 4,800? Oh, I think I know where I went wrong. This is why it's important to write your formulas, you know. Yes, it's 4,825. I'm gonna correct me earlier. Why? Everything disappeared. Okay, let me. Alright, let me try. How much is it? 4,825 coulombs. Okay. So let me just erase that too. Everything disappeared. So it's small E 4,825 coulombs times the amount of atoms, right? Earlier we said that it's 1 atom, and we can just look at one side after we balance, right? In this case, it's just 1 atom present on one side divided by the mole of electron. The amount of electron that we got was 2 right there. That is very important. So it's going to be 2 mole E. When did my hand get so lean? Times Faraday's constant, which is 96,500 coulombs. And then when we do all of this, divided by 2 times 96,500, oh, I got a big number. Let me work this again. And please to work this in brackets. 125 divided by, open bracket, 2 times 96,500 and my answer is 0.025 mole. Finally, step 4. For step 4, we are going to be working the mass. Mass equal moles times molar mass. The moles that we got was 0.025 mole, and the molar mass for this question, I think it was 207. Here it is, lead is 207 g mole. Times 207, and my answer is 5.175 grams as my unit, because mole cancel mole. Right, so that's it for this question. Let me just check if I got all of that correct. Yes, that is what I got for my answer. All right.